Hi, and welcome to a presentation on the importance of geotechnical engineering techniques and practices in subsurface utility engineering.
If you've ever wondered how utility pipes get underground, well, this is the section for you, because I'm going to explain how they're installed. In this presentation, I will cover three types of installation methods for utility pipelines, the first being trenched installation, the second jack and bore installation, and the final horizontal directional drilling. Trenched installation, or commonly referred to as open cut installation, is the most common of all the methods for installing an underground utility pipe. This type of installation is commonly used for pipes being buried at shallow depths. However, a large horizontal area is needed for the trench. Installations can use smaller horizontal areas if shoring is used to support the slope of the trench. Although this method for installation has no need for drilling or boring equipment, road crossings tend to be more difficult because the surface has to be torn up in order to put the pipe in. Here's an animation of a typical jack and bore installation. Jack and bore installations are typically used when stopping the flow of traffic is not an option. Usually larger pipe diameters are used and tend to be smooth due to the method of installation. But because of this, multiple pipes can be installed at once. Because jack and bore method of installation is a slow process, the method tends to create extremely accurate pipe alignments in both the horizontal and vertical directions. Another benefit to jack and bore installation is its ability to go through hard underground rock conditions. Because of this, jack and bore installation is one of the most reliable installation methods that utilizes trenchless technology. Here is an animation showing a horizontal directional drill installation.
The horizontal bore begins with a directional drill bit entering the entrance pit. The entrance pit is used to contain and manage the drilling fluids. The directional drilling crew are in radio communication with each other throughout the entire process. The directional drill bit is tracked by a sonde, our radio detection device, housed within its extended connection to the directional drill pipe. The depth and pitch is sent to the surface and received by the walkover locating device. The locator then gathers and interprets the information and gives directions to the directional drill operator on which way to steer the drill bit. An experienced directional drilling crew can navigate and steer the drill bit up, down, right, left, and a combination of varying degrees of each to drill a desired horizontal bore path. The drilling crew has the ability to determine the exact depth and location of the drill bit at all times. A typical mid-sized directional drill uses a 4-inch drill bit to drill a pilot bore. The bore path is typically enlarged to 1.5 size the conduit that is being installed. In this installation, the bore path has to be enlarged to accommodate the conduit, and a reamer is attached to cut a larger diameter hole. The reamer is simply pulled through the existing bore path to enlarge the hole. As depicted in this video, and as with most directional drilling projects, very little of the normal city activities were interrupted during the conduit installation. After the bore path is enlarged, the conduit is simply pulled into place by the directional drill rig. This method of installing utilities has many benefits that include less disruption of commercial activities, less disruption of traffic, less site rehabilitation, and directional drilling can also be used to avoid damage to wetlands, streams, and for river crossings.
Horizontal directional drilling is perhaps one of the most exciting and fastest growing trenchless utility installation techniques. It is extremely versatile with the ability to drill single pipelines up to 200 meters while changing alignments to avoid any obstacles. Combined with a relative cost effectiveness, horizontal directional drilling allows utility contractors to complete jobs with more ease in less time. In order to maintain the cylindrical shape of the bore, it is common practice that the drill hole is injected with bentonite slurry. One of the common drawbacks to using a bentonite slurry is the possibility of frackout. Frackout's when the bentonite slurry flows through the ground and explodes out the surface. This explosion is so strong it can destroy concrete, asphalt, and other types of grounds. An experienced driller is able to avoid frackout issues most of the time, making horizontal directional drilling one of the most effective installation methods. So now you know how the pipes get underground. Now it's time to learn about how the loads affect these pipes while they're there. There are three types of loads that affect pipes when they're underground: dead loads, live loads, and construction loads. Dead loads are a constant load that the pipe always feels. The dead load is a function of both the unit weight of the soil and the thickness of the backfill layer directly above the pipe. As the total dead load from soil and surface covering increases, the probability of flow complications and structural failure also increases. Live loads are temporary loads that act on the underground pipes that can change in both location and magnitude. Typically, live loads are caused by traffic and other moving loads. Unlike dead loads, live loads felt by underground utility pipes decrease with increasing depth of the pipe. Because the load from the backfill soil layer is taken into account with the dead load, the live load is modeled as a load that dissipates as a function of depth from the load source. Construction loads are a type of live load that are only felt during the construction of the pipe. Construction equipment can induce heavy loads which need to be incorporated into the structural design. Typically, broad surface loads are modeled as vertical flow lines, while local loads are transmitted downwards and outwards in a conical manner. These loads are transmitted through the soil until they reach the underground pipes. In order to properly support the surrounding soil and surface soil directly above it, the pipe needs to share an equal part of the applied load. The biggest factor in the determination of whether a pipe will handle its proper share of the load is pipe flexibility. When compared to the soil, a pipe that is more rigid will take on more than its share of the load, while a pipe that is more flexible will not handle as much of its share of the load. The required flexibility of a pipe is dependent on the soil conditions and how strong the soil is.
Congratulations, you have made it through the presentation. You now know how pipes are installed, how the loads affect these pipes, and how the loads are transmitted to get to these pipes in the first place. Thank you very much. I've been Casey Marika.
That's all, folks.